Hi guys, welcome to my YouTube channel, and as part of this video we will be discussing about Apache Tomcat, right? So if I don't know if you are following my video series, but prior to this particular video I have been creating multiple videos on web servers. So I started with Apache web server. I have also created for Nginx web server, and then we also discussed about the internal design principles of these, the ground level architecture, and the how request handling works in Nginx and Apache web server. Now is the time that we will be discussing about the application server, which is Apache Tomcat. And then before starting into this, right, and today we will have the same agenda in this video as well, where we will be discussing about the internal design of Apache Tomcat. And when I say internal design of Apache Tomcat, because it has a big design, and almost everything has big design, right? But our major focus area will revolve around the request handling part of Tomcat application server, right? So guys, in case you have not subscribed to my channel, I would request you to please subscribe to my channel, right? So that also motivates me to come up with more technical content on this channel, right? So let's quickly begin with this video. So Apache Tomcat is application server. You already know that, right? So the basic difference between the web server, because you might have this question, okay, why do we have application server in first place if we already have things like web server? I'm sure that you will only have this question if you are new to this world. So web server is only, it doesn't has that very large capability, and the basic motive behind having a web server is to serve the static files, right? Or kind of rerouting, handling the request and doing rerouting here and there, the request handling. However, the application server, the main motive behind having an application server is to build large enterprise scale applications. For example, you want to implement a complicated business logic, so this is the correct place to host your application code, right? Also, it also supports the multiple the protocols as well. For example, if your application talks to queue, right? So all those things will be happening using a Java messaging service in case you are using Java. So it also supports JMS kind of protocol. So all those flexibility you get, right, as part of the application server, and it is a kind of stronger machine. It is basically, when I say stronger machine, it's a figure of speech. I actually mean that it can handle the complex things, right, as implementing complex logic. So that's one thing. Second thing, let's talk about, if we talk about the Apache Tomcat particularly, Apache Tomcat also works on the same way that the Apache web server works, right? Which is the concept of one thread per request model. All right. So now how that per request, one thread per request model works, that we will discuss in the depth, right, in the other 50% portion of this lecture. But before that, let's quickly understand the fundamentals component of your Apache Tomcat, so we will get an idea. All right, that's how your request flows the moment your request enters to your container. All right, so you see, so these are the major components involved in the Apache Tomcat. For example, one is Apache web server. So server. So when I say server, you can consider that it's also a class implementation, and somewhere as part of the Tomcat implementation, you may be creating an instances of all these things, right? So server, it represents your Catalina servlet container. Now what is Catalina? The name of servlet container as part of Tomcat is Catalina. So basically, server represents your servlet container. All right. And then so basically, when you create a servlet container, that you might have a configuration file, right? So you may configure the different properties as part of your configuration file, and then the moment you start up your Tomcat, it will pick up all those properties, and accordingly it will tune in all your servlet container, right? Then you have services. So you have a lot of services for a lot of things. For example, let's think about in a way that you have a particular service dedicated to handle the request, right? So for request handling, you have one dedicated service, right? So if you understand the formal definition, it represents combination of one or more connectors that share a single engine for processing incoming request. So, and by the way, all this information, again, even if you look at my other two videos, I have been gathering all the information from the official website. Nginx I have taken from the official websites. However, for Apache web server, I have taken it from I think Apache web server I have taken it from official website. Nginx I have taken from a book, right? The architectures of open source applications. And then this information also I have taken from the official website of Tomcat. So this implementation, the architectural and the design I'm talking about, it belongs to Tomcat 9. After Tomcat 9, you have your Tomcat 10, I believe so, which is stable enough. And then you have Tomcat 11, I think, which is still under alpha. It's not beta version, so I don't think it's the stable version, but you can always cross check, right? It's what I have understood. So service, when I say it, service is a combination of one or more connectors. Now, what is connectors, right? It's another interesting thing. So the basic responsibility of connector, you see the point number 4, if you see right here, specifically I have defined HTTP connector, but if you see any connector, so connector is something that is listening on a particular port. So that particular work, the component which is doing that particular work is basically your connector. All right. And then you have engine. So engine is the main process, right, which actually executes a request. So let's say within your service, when your request comes, so your HTTP connector is the part that which is keep on listening on a particular port number. When the request arrives or let's say a TCP connection gets initiated, then your TCP connector handles that request, take that request and forward it to your engine, right? So that also means every engine, so your connector is being connected to your engine, right? So each service will have one engine. So your HTTP connector will take up that request and forward it to your engine. Now it's the responsibility of engine to fulfill the request. So it could be anything, right? So it could be, for example, you are talking to your database. You're doing a network call to some other external service. You are writing some kind of business logic in the class. All those things will be, although you see, these all things are not visible to you the moment you are writing all the code in your editors, right? IntelliJ, Eclipse, whatsoever. But however, these all things, that's how your request gets handled by your Tomcat server. Right? And then again, we have our main important component. That component that you will find everywhere is your thread pool, right? So thread pool is it also, again, the same concept. It also maintains a thread pool for all the for handling all the TCP connections, right? So thread pool in Tomcat comes with two implementation. One is the standard implementation that uses the basic platform threads to execute the task. Second one is the virtual thread implementation. So I'm not sure if you are heard of virtual thread, but as part of Project Loom in JDK, as part of JDK 21, we have virtual threads, right? And you can create n number of virtual threads. You don't have that limitations of creating virtual thread. You can create any number of virtual threads, right? And they are pretty much faster than the platform threads. So we will create a separate video on the virtual threads. It's a new topic, right? However, we will discuss about the request flow, right? So these are all the components we discuss: server, service, engine, HTTP connector, executor, all those things. Now you see, for example, now you can say that, okay, we have your filter method, right? So the request also goes through, I'm not sure if you are aware, but if you have implemented security, right, in your let's say Spring service, any of the Spring Boot service, or you are using some kind of logging mechanism where right at the moment you are receiving the request, you want to log it into somewhere in the access log. many people does that operation in the filter itself. So filter is also comes as a part of your engine, right? So those all classes, all those things belongs to your engine part, right? So now even if you go to Tomcat official website, they have created a sequence diagram. I can open that sequence diagram, right? Quickly share it with you. Alright guys, so if you look at this diagram, this is the request processing diagram that they have put it in their official website. So this is all the request flow, right, from the class perspective, but you can get an idea, right? So from the thread pool, TCP worker thread executes its runs method, and then which basically process a connection. And this is particularly for HTTP1 protocol, right? So I have already in my one of the video explained you the difference between HTTP1 and HTTP2. So most of the application, although you can tune in your Tomcat application server to use your HTTP2. However, every by default implementation comes with HTTP1. So majorly most of the REST applications are working as of now on HTTP1, right? And then you have this engine, right? If you look at this engine, then all this request is being flowing, right? And then flowing, it's keep going to your, and somewhere you will have your filter. Yeah, you see you have this filter event, right? And then even if you see at this place, you have this do filter method, right? So this do filter method you have, so this is all the chain you have, right? That's how your request is going through from multiple instances of multiple classes. And then you have your service here, and then this is your do filter. And then if you go here, and then if you, yeah, so you see, so this is application filter chain, right? And then this all, then everything is started with your engine value, and then everything is started with your standard engine, right? So this is the basic request flow, but you won't get much idea if you go through the diagram. So I made it simpler for you, and then let's understand the block diagram. So we understood all the fundamental blocks on it. If you still have some confusion, you can always reach out to me on LinkedIn or comment it out on YouTube, or just read through the official documentation of Tomcat. You will get an idea around it, right? So let's move on to next slide, and obviously I will be explaining you this using our drawing, as we usually do in our videos. So this is one thread per request model, where you have your operating system here, and then in a particular port in your operating system, your servlet container. So you have this guy servlet container here, right? So because when because as part of your Spring Boot, it comes as a internal Tomcat application server. Now that Tomcat application server has a servlet container. Servlet container is the main person that does all the jobs, right? Servlet container has a service, dedicated service assigned. And if you go back to the last slide, then you will understand, okay, your service is a combination of different connectors. So here you have a HTTP connector, then you also have your HTTP2 connector, right? And understand that all these ports are keep on listening on your a particular port 80 number, and then this is your engine, and that also inside a service. So one service has one engine. Engine is the one that actually takes up the request and get it processed from your application code, right? And understand these connections, all these TCP connections are being managed by your thread pool. So it's not like that for each request you will be creating a number of threads, right? It's not, it won't work like that, because you will create a fixed number of thread pool, and then the way it will work, this guy connector will see, and if any thread is available, it will pick one connection at a time. If your thread is not available, then in this particular case, it will cache, or it will not cache, it will queue all the connections right here. So let's understand use case one. Use case one is these guys connectors are looking at your port number, a TCP connection gets initiated and thread is available. It will go, and so this particular thread will pick up this connection. So this thread will get assigned to this connection, and it will take up this request and take it to the engine. Now this engine will particularly invoke all your application business logic, talking to database, and then invoking your API calls, etc., all those fancy things, and it will prepare a response back. It won't prepare a response back. Your application code will prepare a response back, and then this whole thing will come back via filter, and all those things will happen, and then this whole data, this response will go back via the same port to your client, right? So here at this, somewhere at this place, you have your client. Although I have not put it here in this slide, but that's okay. Second case, let's understand that you have your connection now, because you cannot keep on creating a number of threads, right? Because it will give you the performance degradation, right? Because every thread also utilizes some resources. So now let's say your thread is not available. All threads are engaged in serving your connections, right? And this is all synchronous, right? So that's the problem with one thread per request model. When I say synchronous, that means a thread will pick up one connection, and then for that particular connection, it will take up that request to the engine and will process it. But till the time that particular request gets fulfilled, or that particular response gets prepared, or let's say that particular request gets served, this thread will be engaged or blocked to that particular request, right? So that's the problem with application server. So all your Spring Boot applications that you create, you develop as part of today, these are all synchronous in nature, right? These are not non-blocking. These are all blocking. This is all blocking code we are writing. If you want to switch to, let's say, non-blocking code of your Spring, you should be using your reactive Spring, right? Or people call it Spring Reactive whatsoever, but the idea is that Spring Reactive works on your project reactor, right? So everything is non-blocking in nature, so it gives you more performance. But again, the debate between having your blocking versus non-blocking also depends on what requirement you have. So you cannot just go blindly and start implementing non-blocking code and expect that code to perform very well. That's not the case. No, one solution fits all this is not the solution that you can apply everywhere. You will have to first understand the requirement. If you think so that it can work well, you should go ahead. So now so we understood, okay, one thread will pick up one request at a time and will take it forward to the engine, and till the time request is served, that particular thread will be engaged for that particular connection. Now what happens when your thread is, let's say, none of the threads are available, all threads are engaged, so but you still have connections coming in in your servlet container? In that case, you have a value max connection. So there is a variable value max connections in your container as part of your container properties, where you define the value of max connection. So let's say you define the max connection is equal to 10. So if your thread is not available to serve your connection, so your all these connections will be queued inside this particular queue, right, in the servlet container. So now let's say a thread gets free, right, from serving the request. Now it will go and pick up one connection from your queue, and the same way all these connections will be processed, right? Now think of the case that you are getting maximum number of concurrent connections, but your servlet container is not in the situation to process all the threads. Now what happens, this particular queue is also gets filled. So now in this case, the huge number of concurrent your connections coming to your servlet container, in that particular case, when this queue is full, then this queue which belongs to your operating system. So your operating system will be also manages input output queue, so it will be queuing all the connections, the TCP connection which has been made to your operating, because that's how it works, right? Your connections being made to your operating system, from your operating system everybody listens, right? So it will queue all the connections right here, and the moment all these threads gets free, it will start taking up all the requests from here. So that's how your one request per model works. And then because of its synchronous and blocking nature, this does, although it performs well, it still raises a question mark, but I cannot comment that it doesn't perform well, because it again depends on the requirement and the way you are implementing your code and multiple other factors, the infra and the resources, all those things. But So this debate between if this model works well or not, again it's a very huge debate, we cannot question on that, but so we have understood this from this slide, so let's go to your drawing and quickly understand how it works, right? In case you have left something, you will try to cover a bit, right? I'll hardly take 5 minutes to explain you. All right. All right, so we have your client here, right? Or now let's say now this client is sending all the TCP connections here, right? So this is TCP connection, it's creating with the operating system, right? Now from your thread pool, right, here you have many threads, right? So this is nothing but your thread pool. So now if your thread pool is available, if your thread pool has some available threads, right, so it will simply, the one thread will be allocated to one request, right? So this will take one request, so this is, let's say, T1, so this T1 will take up your request 1 and will take it to your, again all these things will come here, the connector, let's say, and then it will take up this request to your component, which is your engine, right? And then after engine, so let's say all this application code that you have here, this engine will be doing all those things and passing all this requests from all those classes that I've shown you, right before some time. It will take it to your application code, and from here, if you are talking to a database or if you are talking to some other service, then all those things will happen. And then after that, this will, so again this your request is flowing here, and then this is your request, this is again your request. Now from here, this application code will send a response back, this guy will also respond back, right, and it will send a response back, and then this response back will be sent to your clients, right? So that's the, and then till the time this whole process is over, right, till the time this whole process is over, this thread will be blocked, right? So is synchronous in nature. So is it synchronous in nature? When I say it's blocking in nature, right? So that's the that's one kind of limitation I personally feel with the implementation of Tomcat, right? Because it's blocking in nature. Because nowadays we have many things that are in non-blocking in nature. For example, you have Node.js that works on V8 JavaScript V8 engine, which is also one on an event loop mechanism, and the same way you have Spring Reactor that works on the project reactor, again this event loop mechanism, and how these things take benefit of being non-blocking in nature and enhances the performance. So that we will cover in a different topic. But so far we understood that is how at the ground level your Tomcat manages a request per thread, right? And these are the fundamental components involved in it, right? So you can go to the official website of it, but by this time you might have gotten basic idea around how Tomcat works. And then we day in day out we have been using these things, right? But it's good idea to understand that how things are working. That is the fundamental base and the beauty. So if you really want to be good at the system design, then these all building blocks, you should understand the concept that how these things are moving, how these things are working, right? So try to understand the fundamental concept, question it, try to get it clear, right? So that's the beauty of computer science. So for this video, this is it, guys. So probably in the next lecture I'll come up with some other topic. So but in my next lecture, what I'm thinking is to come up with a topic that I have created is the service mesh. So probably I'll cover the service mesh, what is service mesh and how it works, probably the distributed system, and some other topics, for example data partitioning, zookeeper, designing resilient systems, building a scalable web application, so on and so forth. So I hope you are enjoying my videos. If you really have some feedback, I would appreciate and welcome that. Please, you can reach out to me one-on-one to my YouTube and LinkedIn, right? And then if you want me to create any videos of other topic, you can comment it out and reach out to me on LinkedIn. So this is it, guys. Thank you so much. We'll meet again in the next video.